Okay, so in this set of problems, this progress check part B, this is, I think, the only calculator question. Alright, I'm going to do this two different ways in the calculator. So first they say let g be the function given by g of x equals x to the fourth minus 3x cubed minus x. And then they ask, so they give some random function. They ask, what are the values of x such that the derivative of g equals a half? Okay, so two ways. Since this is just this is just a polynomial function, you could actually just find the derivative of g by hand. Okay, and then we want to know when does this equal a half? Okay, so if we go to the calculator, go to y equals. If you have anything in there, just go one by one and clear. This is pre-recorded, so I'm just kind of narrating, I guess. Okay, and then just type in that derivative that we found. Okay, and then we want to know when does it equal a half. So we're going to graph the function, and then we're going to graph a half, constant function, and then we're going to see where they intersect. The x value where they intersect is the answer. It's where they both equal a half. One equals a half all the time, but right there they both equal a half. So we got to find that x value, do second trace, which is calc, and then number 5, intersect. And then just move the cursor as close as you can to that intersection point, and then just hit enter 3 times. Okay, and you can see that x value here. That's the answer, and that's why answer C in this case. Okay, a different way of doing it, so C is the answer, but different way of doing it. So there's a way to, we found the derivative, and then just graph the derivative and graph a half and saw the intersection. So there's another way. I'm going to type in just g. Notice I'm just typing in just the regular function that was given. And there's a way in the calculator, and the calculator can't find derivatives, but it can graph a derivative. And so we'll go to Math 8 for derivative. And then we'll take the derivative of y1, which is g. So go to vars, go over to y vars, hit enter for all the functions. Those are all the y's and y1. And then we'll do x equals x. So that's going to graph the derivative, just like we did before. Before we found the derivative by hand. Here, this is the derivative that'll get graphed. Okay, but we don't want to graph the original function. So just go up and highlight the equal sign, and then hit enter, and it'll unhighlight it. So now this will graph just the derivative and a half, just like before. So notice that's the same. Those are the same graphs. Okay, so we'll find that intersection point again. Doing the same thing, second trace, which is calc. Go down to 5, and here it's the same thing as before. Okay, and you can see the same intersection as before. And that's it. Okay, so this is C is the answer. Yeah, so two different ways of doing this one. All right, for the next one, they say let f be the function given by f of x equals x cubed plus 3x squared minus 4. And they ask for what's the value of f prime at 2. Okay, whenever you're given a function and you're asked for the derivative at a certain x value, you always have to find the derivative as a function first, and then plug in whatever value. Okay, so here. All right, and these are just power rules and constant multiple rule and sum and difference rules. Okay, so first just do the power rule for x cubed, 3x squared. Okay, and then technically you're doing the derivative of x squared, which is 2x, and then timesing it by 3, so it'll be 6x, but really just take the 2 and multiply it by the 3. That'll be 6x. Alright, and then the derivative of a constant, since it doesn't have x's in it, if there's no x's, then the derivative of that is 0. Okay, so now we found the derivative as a function, and then just take that and plug in the x value. Just replacing all those x's with 2's. 2 squared is 4, times 3 is 12. That's 24. So the answer is B. Okay, so they give a polynomial function, f of x equals 4x to the 6th minus 3x to the 4th plus 2x cubed plus e squared. And then they ask for the derivative. Okay. Alright, so we're going to start off just like the last one, and just do some power rules and constant multiple rules and sum and difference rules. Alright, so this f prime of x, there's just one tricky thing that they're trying to trick you. Alright, so 24x to the 5th. Okay, now, derivative of e squared. So the fact that, there's kind of different ways that people might accidentally look at this. So you might look at this as an exponential function, or you might look at this as like, just like these terms. So this is just a constant. Notice there's no x's. E is just a number, 2 is just a number. So this whole thing is just some number. I don't know, maybe 8 point something or 7 point something. And so the derivative of a constant is 0. So notice they put 2e. If you did the power rule with this on accident, you would get 2e maybe. But really this derivative of this term is 0. And so this is just the answer. Okay, so that is B again. Alright, so here they're given trig functions, so we have to remember what the derivative of the different trig functions are. And that's just memorizing. Alright, so first they give us g. G is 4 cosine x plus 2 sine x plus 1. So first we'll find g prime of x, and then we'll plug in pi over 6. Okay, so remember just little things. Anytime you have a trig function that starts with a c, cosine, cosecant, cotangent, those derivatives are always negative. And so derivative of cosine is negative sine, so that'll be negative 4 sine x. Derivative of sine is cosine, that'll just be plus 2 cosine x. And the derivative of 1, since that's a constant, is 0, so that just goes away. So now, after we found the derivative as a function, now we plug in the value that they say, pi over 6. Alright, and then just have to remember, sine of pi over 6 is a half. And then cosine pi over 6 is root 3 over 2. Okay, half of 4 is 2, negative 2. And then these 2's cancel. Okay, so that's A. Alright, I thought this was probably the trickiest problem on here. So they say let g be the function given by g of x equals limit as h approaches 0 sine of x plus h minus sine of x over h. Okay, and then they ask for what's the instantaneous rate of change of g with respect to x at x equals pi over 3. Okay, so they want to know, so g is given as in terms of this this limit. And then they ask for the rate of change of g, so instantaneous rate of g. So they're really asking for, so you know, anytime they say instantaneous rate of change of g, they really mean g prime. Okay, so we have to find the derivative of g, but let's figure out what g is. Let's kind of rewrite this. So this is just the derivative. And so really g, just g, not g prime yet, is, so we can kind of translate this. This is derivative of sine, and so that's cosine x. Okay, so we had to find a derivative just to get what g is, and then now we'll take another derivative. So to get g prime, now we take derivative of cosine, which is negative sine. Okay, and then now they say instantaneous rate of change, which is derivative at pi over 3. So just negative sine pi over 3. Okay, and then sine of pi over 3 is root 3 over 2. So this is negative root 3 over 2. So that's A. All right, so the AP test will put a good amount of these on there. Not a ton, but where they're putting the definition of derivative. This is a definition of derivative type question, but they're with this particular one, they're being super tricky. Okay, so we got to be careful. So you know the formula in general for definition of derivative as a function. Okay, now two things. So here in this, the f of x plus h comes first, and then the regular function comes second. Notice they're switched here. Okay, so if you're given this, we want to rewrite it to make it look like the definition, so that we can, you know, once it looks like the definition, then we can rewrite it as just the derivative. Okay, so that's one thing. So these have to be switched. And then also there's just this random 3 here. You know, here it's just an h in the definition, but they have some random 3, and so we'll have to factor that out also. Okay, so we're going to do two things. Two things with this. Okay, so first we're going to factor out that 3, but it'll come out as a 1/3 since the 3 is in the bottom. Okay, and then we're going to switch these. And so remember, anytime you switch two things that are subtracted, then you have to put a negative sign somewhere on the outside. Okay, and then just somewhere we'll kind of put a negative here, and that's because we switched these. Okay, I'm going to rewrite this just a little bit. So we can actually pull out this 1/3 from limits. Anytime you have a limit of a number times something, you can always factor out that number or pull out that number. now we compare this to definition of derivative. So notice in the definition of derivative, the derivative, we're taking the derivative of function, and the function is right here. The second thing being subtracted. Okay, and so here for us, this second thing being subtracted is 5e to the x. So that means our function is 5e to the x. Okay, and so that's the function here, and then we'll take the derivative of that function. So f prime of x is the same thing. So derivative e to the x is just e to the x, and then you just bring down the constant. That's the constant multiple rule. Okay, but that is really what this is. So that's 5e to the x, and so we times that by negative a third. And then now the negative 1/3 times 5 is negative 5/3, and that's e to the x. Okay. So that is C. Okay, so now we'll do question 7. They say the function f is given by f of x equals x cubed plus bx plus 6 times g of x, where b is a constant and g is a differentiable function satisfying g of 2 equals 3 and g prime of 2 equals negative 1. Again, then they ask for what values of b is f prime of 2 equal to 0. Okay, we'll kind of start with this. So we want to know, where does f prime of 2 equal 0? So basically we're given f, so first we'll find f of x by just taking derivative, and then we'll plug in 2. That'll give us f of 2, and then whatever we get for that, we'll set that equal to 0, and then hopefully we can we'll have all the information we need to solve for b, just have b's in numbers. So okay, so let's do that. So first we'll find derivative. Okay, since f is two things multiplied that are each functions of x, we'll have to do product rule. And it doesn't matter the order, but I'll take the derivative of this first for this one. Okay, derivative of x cubed, 3x squared. Derivative of bx is just b, and the derivative of 6, since that's a constant, is 0. And we'll just multiply that by g of x. Okay, then we'll rewrite the first one. And then just times that by g prime. Okay, so we did derivative of this times this. That's how we got that. And then we just left that alone and multiplied it by the derivative of g, which is g prime. Okay, now we'll plug in 2 everywhere because we want to find f prime of 2, so we can set it equal to 0. Okay, so just everywhere where there's an x, just replace it with a 2. Start simplifying this. Okay, so 2 squared is 4 times 3 is 12. Okay, now we can see why they gave us this information. So g of 2 equals 3. So that g of 2 is 3. Okay, then we'll simplify this. 2 to the third is 8 plus 6 is 14. Okay, and then g prime of 2 they give us here is negative 1. Okay, that's f prime at 2, and so now we'll set this equal to 0, and that'll, according to what they ask, and then we'll find the value of b that makes f prime of 2 equals 0. Okay, so we'll just start simplifying. So here we'll distribute this 3. Okay, and then distribute that negative. So negative 14 minus 2b equals 0. All right, then start combining like terms. 36 minus 14 is 22. And then 3b minus 2b is just b. And so b is negative 22. All right, so that's d. All right, here they give us a chart. Just to see clearly what this chart is. So, this x value is 4, and then each of these are basically these different functions and derivatives of functions at 4. So this is f of 4, this is f prime at 4, this is g of 4, and this is g prime of 4. So all these functions and derivatives are at x equals 4. All right, then they say table above gives the values of the differentiable functions f and g and their derivatives at x equals 4. Then they ask for what's the derivative. So this notation is just derivative of, and then two functions multiplied, f and g. All right, the fact that there's these functions f and g are multiplied, we'll have to do product rule. So we'll do f prime x times g of x, and then just regular f of x, and then take derivative g. Okay, just little notation things. Anytime you want to evaluate something, you can put a little line, and then put what you want to substitute into the expression. Yeah, so usually when you want to evaluate some expression, especially in calculus, I don't know why they do it in calculus more than other subjects, from my experience. All right, and now we just substitute 4 into all these. And then now just substitute values from the chart. Okay, f prime of 4, that's 7. And then g of 4 is 3. F prime of 4, f of 4 is 2. And then g prime of 4 is 5. So now we have a function that's defined as square root of x times cosine x, and then they ask for derivative. Okay, two things. First, anytime you're taking derivative and the function is defined or has a square root somewhere, or any kind of root really, you always have to change that to a fractional exponent. Okay, so square root is to the 1/2. So even before we take derivative, we'll just rewrite the function. So square root of x we'll rewrite as x to the 1/2, and then just times cosine x. Okay, now that we've rewritten the function, now we can take derivative. All right, notice this is two functions of x multiplied, so we'll have to do product rule. Okay, in product rule, I'll take the derivative the first thing first. So derivative x to the 1/2, we'll have to use power rule. So bring the exponent out front, and then subtract 1 from 1/2. Just rewrite cosine. And then derivative of cosine is negative sign, so really this is going to be a minus. And then we rewrite x to the 1/2, so basically just rewrote x to the 1/2, and then derivative of cosine is this negative sign. So, all right, and then if this is a free response question, or part of a free response question, you could leave your answer like this, but you have to know how to simplify these in order to get your answer to look like a multiple choice answer. All right, so notice in the different multiple choice answers, notice they're all over 2 root x. So we're going to have to get this into all one fraction with 2 root x in the bottom. Okay. So this, the fact that this is a negative exponent, actually I'm gonna kind of go over something, kind of the best way to do this, I think. So anytime you have, and this is going to happen a lot, where you have multiple terms, but they have, the same term, in this case just x, but to different exponents. And you can always factor these out, and when you factor out, you always factor out the term with the smaller exponent. So negative 1/2 is smaller than 1/2, so we'll actually factor out x to the negative 1/2. Okay, now we're factoring it out of this, so we're just going to rewrite 1/2 cosine x. Okay, and then when you factor out, we're really factoring an x to the negative 1/2 from an x to the 1/2. You always subtract exponents, and so you really take the original exponent and subtract the exponent that was factored out. So basically you're doing x, or you're doing 1/2 minus a negative 1/2, which is plus 1/2. So 1/2 plus 1/2 is 1. And so that's x to the 1, so just x. Okay, and you can kind of check your work. If you took this and distributed to these, you'd see you'd get back this. Okay, so technically x to the negative 1/2 is 1 over x to the 1/2, which is 1 over root x. Okay, and then this is cosine x over 2 plus, and I'm going to rewrite this as 2x sine x over 2. All right, and there's different ways of doing what I'm doing, but okay, so now we can see the answer. So we'll do 2 things in this step. So now that we've got a common denominator, we can combine these into one fraction, and then we'll just kind of multiply it by the root x, the denominator. So this is going to be cosine x plus 2, and then we'll times it by the root x. So that'll be, should be the answer. Let's see. Yes, that's D. All right, so different ways of doing this algebra to make it look like one of the answer choices. But I think this is like a nice thing. Anytime you have two different factors, or you have a factor with 2 different exponents that are in different terms, and you want to factor it out, always factor out the term with the smaller exponent. And then when you're factoring it out, you always subtract exponents to get the new exponent. So this would be an exponent of 1 here. Yeah, and we'll do that. We'll do more of that later. Okay, question 10. They give us a function that's a fraction, and there's x's in the top and bottom. All right, and they ask us for what's the derivative at x equals 1. So f prime, or x equals negative 1. All right, so the fact that we have a fraction with x's in the top and bottom means we'll have to do quotient rule. All right, when you do quotient rule, you always start off with derivative of the top first. So derivative of 2x squared minus 1 is just 4x. The minus 1 is a constant, so that goes to 0. And then we'll just multiply that by the bottom. Just rewrite the bottom. Okay, always minus. And then we'll rewrite the top. And then times that by the derivative of the bottom. Derivative of 5x plus 3 is just 5. Okay, and then the bottom, you put the original denominator and then square it. Okay, my advice for this is now just don't try to simplify this in terms of x. Plug in the number and then now just simplify the numbers. So first just plug in -1 everywhere you see an x. And I'll kind of simplify as I go along. So 4 times -1 is just -4. Okay, and then if you plug in -1 for x here, that's -5 plus 3. It's -2. Right, and then if you plug in -1 squared is 1, times 2 is 2, minus 1 is 1. Okay, and then we already know, so 5x plus 3 when you plug in -1 is -2. So this is -2 squared. And that's 4. All right, and then we just start simplifying. So -4 times -2 is 8. That's 5 over 4. And so that's C. Okay, here they give us the graphs of f and g shown above. And then they give us they define some other function h in terms of f and g in a certain way. Okay, and so now this is, h is a fraction, and it's got x's in the top and bottom. And then they ask us for the derivative of h at 3. Okay, since h is a fraction with x's in the top and bottom, that means when we take derivative, we have to do quotient rule. Okay, and then we'll plug in 3, and then we'll kind of look at what we have after we take derivative and plug in 3, and then we'll probably go up to the graphs and be able to look at the graphs and substitute in actual numbers. Okay, so quotient rule, start off with derivative of the top. So derivative of f, we'll just have to write f prime since we don't know what f is. Yep, exactly. I mean, it's got the graph, but. And then derivative of 4 is 0. Okay, then we'll times it just by the bottom. Okay, minus. Okay, now we'll just rewrite the top. Okay, and the derivative of the bottom, so derivative of g is g prime, and derivative of 2x is just 2. So this is g prime of x plus 2. Right, and then this is just the original denominator squared. Okay, now we'll plug in 3 everywhere we see x. Alright, so now to get these values, or to get a lot of the values in here, we'll have to look at these graphs now. Okay, so notice like in our derivative, we've got f prime, and then regular f, we've got g prime and regular g. So anytime we're talking about just g or just f, those are going to be just y values on these graphs. And then anytime they talk about f prime and g prime, that'll be slopes of these graphs depending on what the x value is. Okay, so first thing is f prime at 3. Okay, so that's the derivative of f at 3, which is the slope of the tangent line at 3. Okay, since this is a linear graph here, for this portion of, around where x equals 3, the derivative of just a linear graph is the slope of this line. So we'll just do rise over run. So up 1 over 2. So this slope is a half. And so f prime at 3 is a half. Okay, so next thing, g of 3. That's just the y coordinate at 3, which is 2. Okay, that's 6. Okay, next thing, f at 3 is just the y value at 3, so that's 4. Okay, again, g prime at 3 is the slope of the tangent line at 3. And so we're looking at this piece here, not this piece. So the slope of this piece is negative 3. And so that means f prime at 3 is negative 3. Okay, and then notice every time you do quotient rule, this is g of x, and then this is g of x, or this is the original denominator, and this is the denominator squared. So whatever this is, you just square it in the bottom. Alright, and then now we just simplify this. And different ways of doing this, but okay, so this is 8. Half of 8 is 4. Okay, this is 8, and this is negative 1. And so 8 times negative 1 is negative 8, so this will really be plus 8. Okay, the bottom, 2 plus 6 is 8, squared is 64. Right, and then these are both divisible by 4, so divide each of these by 4. And you get 3 over 16, so that's answer choice C. Okay, so when they say, so this problem says, what's the slope of the line tangent to the graph of y equals 9x squared over x plus 2 at x equals 1? Okay, right when you see them saying the slope of the tangent line at x equals 1, they mean find the derivative and plug in 1. Slope of the tangent line is derivative, and whatever x value they say is what you're going to plug in after you take derivative. So this is really y prime at 1. Okay, so first we'll just find y prime, and we'll have to do quotient rule. Okay, I'll do this one quicker. So 9x squared derivative is 18x. Just times that by the bottom, minus top times derivative of the bottom. Derivative of x plus 2 is just 1, so we don't have to write that. Okay, this is a valuation bar, so we'll evaluate it at x equals 1. Alright, just plug in 1 for all those x's. 18 times 1 is just 18 times 3. And then the bottom is 3 squared, which is 9. Alright, you can, a bunch of different ways of doing it. I'll kind of do it like this, like cancel out those. Divide all those by 9, basically. So 2 times 3 is 6, minus 1 is 5. Oops. Okay, so that's answer choice B. Okay, pure memorization. Derivative tangent is secant squared. Okay, pure memorization again. Derivative cosecant is negative cosecant cotangent. Alright, so this one, question 15, last multiple choice question. They say below is an attempt to derive the derivative of secant x using the product rule where x is in the domain of secant x. Okay, in which step, if any, does an error first appear? All right, the first step, we might not know exactly what they're doing yet, but we know that that's true. If you do secant times cosine, you get 1 because secant is 1 over cosine. So 1 over cosine times cosine, the cosines would cancel, and that's 1. So we assume that that's not an error since that's just a true equation. Okay, look in the next step. You have secant cosine, but you're taking the derivative. So that means they took the derivative of the left-hand side, and that's how they got this. Okay, but if you take derivative of the left-hand side, you have to take derivative of the right-hand side. Derivative of 1 is 0, so that looks good. So they just took derivative both sides to get step 2. Okay, next thing they did, looks like they did product rule. If you're taking derivative of these two functions of x multiplied, you have to do product rule. So first they took the derivative secant, and we're trying to derive the derivative secant, so we're kind of pretending like we don't know what the derivative secant is, and so we'll just write it as d dx of secant for now, and then later we'll solve for this. Okay, so we took the derivative of the first thing and then just multiplied it by the second thing. That's what they did. And then plus, should be plus, but now you rewrite secant, and then, which they did, and then derivative cosine is negative sign, and that's why this turned into a minus. And then just rewrote equals 0, so that looks good. All right, so now we know the answer is going to be D. There isn't an error since step 4 is not an option. All right, and then we can just look at to see what they did, just if you're curious. So here, now we want to solve for this d dx of secant, derivative secant. And so now just add secant x sine x to both sides and then divide by cosine, and that's how they got this. And then they just separated it, sine over cosine here is tangent, and so derivative of secant is secant tangent. Okay, so that was all good. No errors in that one. All right, so this is the first FRQ from part B. Okay, so notice they give us two different graphs, one of f and one of f prime. So we've got to be real careful which graph to use and which situation. Okay, so they say the graphs of f and its derivative f prime are shown above for x between -1 and 4. Okay, find the average rate of change of f over the interval from -1 to 4. And then they say for how many values of x in the interval from -1 to 4 does the instantaneous rate of change of f equal the average rate of change over that interval. Okay, so let's first find average rate of change. So remember, average, every time they say average rate of change, they mean slope formula. So this will be like f of b minus f at a over b minus a. So no derivatives, no calculus. Average rate of change is just a little algebra thing or geometry thing. Okay, so let's do that. So, and the interval that we're dealing with, it's always got to be average rate of change on an interval. And the interval is -1 to 4. Okay, so that means that, like in this slope formula, a is -1 and b is 4. So average rate of change is f of 4 minus f of -1 over 4 minus -1. All right, so now we'll go up to the graph to substitute these values. So f of 4 is 1, and f of -1 is -2. So f of 4 is 1, and then f of -1 is -2. And then in the bottom, 4 minus the negative 1 is 5. 4 plus 1. All right, 1 minus negative 2 is 1 plus 2. Okay, so that's our first thing. Okay, now they say for how many values of x in the interval from negative 1 to 4 does the instantaneous rate of change. Okay, so every time you see instantaneous rate of change of f, remember this is always f prime. Okay, so now they want to know when does the instantaneous rate of x equal the average rate of change of f over that interval. Okay, so we already found the average rate of change, so we just want to know when does the instantaneous rate of change of f equal the average rate of change over that interval. So that's 3/5. So we want to know when does f prime equal 3/5. Okay, and this for this we don't need to know the x values where it equals 3/5. We just want to know how many times it equals 3/5. Okay, so we can do this two ways. The fact that we're given derivative, I think that'll be easier to use this. Okay, so notice 3/5 is maybe right around here. So I would make just a horizontal line at 3/5. And so every time the graph crosses 3/5, this x value, the derivative will be equal 3/5, and then whatever this x value here is, the derivative will equal 3/5 there. So we know the answer is 2 right now. Actually, we'll just do it that way for now. So now we know. So, and for how many values of x? So we'll just say the instantaneous rate of change of f equals 3/5, which is the average rate of change, twice. Okay, next they say write an equation for the line tangent to the graph of f at x equals 1. Okay, right away, we'll use point slope. We can do this different ways, but I think point slope kind of makes the most sense, especially when you're first learning this. So they ask us for the equation of some straight line, so we can always use point slope form to find the equation of a line. So it's y minus y1 equals m times x minus x1. Okay, so for us, we've got the x value is 1. So we know that the x1 is 1. And so the y value is just whatever f at 1 is. So we can kind of write that. So this is really y minus f at 1 equals, okay, and then we want the equation for the tangent line. And so here, this is the slope of the tangent line, and slope of the tangent line is derivative. Okay, and this is derivative at 1, whatever x value they say. Okay, so now we go up to these graphs to find these values. So we need f at 1 and f prime at 1, really. graph f at 1 is 2, and f prime at 1 down here is negative 2. Yeah, so f prime at 1 is negative 2. So f of 2, or sorry, f of 1 is 2, f prime at 1 is negative 2. So this was 2, and the derivative was negative 2. Okay, and you can leave your answer like that if you want, since this is a free response. But here, I'll, in case people want to see it in the slope-intercept form. And then just add 2 to both sides. Okay, so this could be an answer, or if you want to solve for y, you can get it like that. Okay, so same question, just parts C and D we'll do now. Okay, so part C says for each of limit as x approaches 2 of f of x minus f of 2 over x minus 2, and then the same thing for x equals 3, limit as x approaches 3 of f of x minus f of 3 over x minus 3. Okay, so for each of those limits, find the average value, find the value, or give a reason why it does not exist. Okay, so these are each a certain definition of derivative. So the definition of derivative that they're using here is f prime at some c value, some x value, is limit x approaches c, f of x minus f of c, x minus c. Okay, so notice when they give these limits, they're given the right-hand side. So we can just rewrite these in our derivative forms. And then now, instead of evaluating these limits, we can just take the derivatives, which are either using rules, or in this case, we're not given f as a function, so we can't use derivative rules, but we're given graphs, so we can use the graph. Okay, so notice that here f of x is just f of x. Here, do you see 2 is where these c's, and really all these 2's are really all these c's. So really c is 2. And so really this whole limit is really just asking for f prime at 2. And then in the same way, this one's just asking for f prime at 3. Okay, so f prime at 2, we can just go to the graph of f prime, and f prime at 2 is 1, just the y value. Okay, and then f prime at 3, see there's 2 open circles here at this jump discontinuity, and so there's no point on here, there's no point here, no point here, and no point anywhere at x equals 3, so f prime doesn't exist at x equals 3. Okay, and so that would be, the explanation is, they ask us to explain or give a reason, and we can say because the graph of f prime doesn't have a point defined at x equals 3. Okay, another explanation would be is if you look at the graph of f, and you can see there's a corner at x equals 3, and so you can also talk about that could be a reason also. So the derivative of f at 3 doesn't exist because there's a corner, or you could say that the derivative from the left doesn't equal the derivative from the right. Okay, so any of those could be, so there's a few different reasons that you could give, and all of them are perfectly fine, I think. Okay, last one, they say, they just kind of introduce some new function g. They say let g be the function defined by g of x equals e to the f times f of x. So we've got f of x up there, but g of x is just some brand new function that they defined kind of in terms of f of x and some e to the x function. Okay, they ask us for g of 0, so first we'll just start off taking derivative of g just in terms of x, and then we'll plug in 0. Alright, since g is written as two things multiplied, we'll have to use product rule. So derivative e to the x is just e to the x, and then times that by f of x, and then just rewrite e to the x and times that by derivative f. Okay, now just substitute 0 for all these x's. Everywhere you see a 0, or everywhere you see an x, place that with a 0. Okay, and then e to the 0, just like anything to the 0, is 1. So those just kind of go away. Okay, and then now we just really need to add f of 0 and f prime of 0. So we'll go up to the graphs. Okay, so f of 0 is 3, and f prime of 0 is 1, and that's it. So this is really just 3 plus 1, and that's 4. Okay, so for the second FRQ, okay, they give a chart and they explain it. So the number of passengers who have boarded a ship is modeled by the differentiable function p, where t is the number of hours since boarding began. Okay, values of p at t for selected values of t are given in the table above. Okay, so always good to just kind of check out the table. So just these kind of different hours, this is 6 hours after boarding, 3 hours after boarding, and at each of those times, this is the number of passengers that have boarded in total. So it's kind of like a cumulative amount of people that have boarded at each point in time. Okay, for part A, they say according to the model, what's the average rate of change, or average rate, sorry, at which passengers board the ship in passengers per hour over the time interval 1 to 8. Okay, so remember, every time you see average rate, this is slope formula. So this is not calculus, this is not derivatives, this is just f of b minus f of a over b minus a. Okay, our function is p, so this is really p of 8 minus p of 1 over 8 minus 1. Okay, so now we go to the chart. P of 8 is 728, p of 1 is 35. Okay, and then, let's see, 7, so that's 693 over 7. And then that's really 104 minus 5. Okay, so I think that's 99. Yeah. Okay, and this is passengers per hour. Okay, next one. They say write p prime of 4.5 as the limit of a difference quotient. And so that's just according to the definition of derivative. Okay, use the data in the table to approximate p prime at 4.5 and show the computations that lead to your answer. Okay, so first let's rewrite p prime at 4.5 as the limit of a difference quotient. Okay, so we're going to use we actually have two options. There's two different definitions of derivative at a point. So we could either use, I'll just write them both. Just you wouldn't write this as a, but I'll do it just to explain this. Okay, so one definition of derivative could be limit as h approaches 0. Okay, and then this would be, I'll give the general one. This is f of a plus h minus f at a over h. And so for us, for our function, this would be limit as h approaches 0 of p of 4.5 plus h minus p of 4.5. Okay, so that's one way to do it. A second way to write the difference quotient would be limit, the general form, limit as x approaches c of f of x minus f of c over x minus c. So for us, in this context, it would be limit as x approaches 4.5 of p of t. Oh, that should be t's. So no x's here. Oops. Okay, the limit as t approaches 4.5 of p of t minus p of 4.5 over t minus 4.5. Okay, so either one of these you could give as the limit of a difference quotient. Okay, so just see this, each of these fractions are called difference quotients, right? Notice there's a subtraction in each of them, so that's a difference, and then there are fractions, so that's quotient. And so that's limit of a difference quotient in each case. Okay, and then they say use the data at the table to approximate p prime at 4.5. Okay, so whenever you want to whenever you're given a table or given information and you want to approximate the derivative at a certain point, notice that 4.5 is kind of right in between 3 and 6. And so really we'll use these numbers, these points really. So each of those is a point. This is a point 3, 204, and this is a point 6, 600. Okay, and we'll basically just find the average rate of change, which is just the slope between those 2 points. Okay, so let's rewrite this down here. I'll rewrite these points. All right, and then we want to approximate derivative at 4.5, so it'll be approximately the slope between these two lines. So that's p prime at 4.5 is about 132. Okay. Must there be a time t? So part C says, must there be a time t for t between 3 and 6, at which p of t equals 500. Okay, so hopefully you recognize this as an intermediate value theorem question. You know, one tip-off is that they're not asking what's the value of t where p of t equals 500. They're just asking if a value of t exists where p of t equals 500. Okay, so that, you know, the fact that they're asking if something exists, that's usually going to be an intermediate value theorem question. Okay, so with these, you know, like with this particular one, the only points we know between 3 and 6, you know, including 3 and 6, is at 3 and at 6. So let's write those. So p of 3 is 204 according to the chart. And then p of 6 is that 600. Okay. So notice that 500 is in between these. Okay, so that means that you could say, and there's different ways to say this, but you could say something like 204 less than or equal to 500, which is less than or equal to 600. Actually, probably the best way to write this, probably basically just saying 500 is in between p of 3 and p of 6. So since 500 is in between p of 3 and p of 6, you could say by the intermediate value theorem, there must be a value of t in this case where t is between 3 and 6 such that p of t equals 500. Okay, and so that would be the answer. Okay, just to understand this also, for anybody that kind of hasn't understood the intermediate value theorem yet, let's say that's 3 and that's 6. So we'll just plot these. So p of 3, let's say that's 204. And then p of 6, let's just say that's 600. Okay, so I'm just plotting these 2 points, 3 comma 204 and 6 comma 600. Okay, you can see 500 is like right here. There's the line that's 500, right? So that means that if this function's continuous, oh, actually I have to say that. We'll figure that in a second. So the fact that this function's continuous, it has to cross this line at 500 at some point. In order to get from this point to this point, it's got to cross over 500 at some point. So the function at some point, since it's continuous, has to equal 500. And that's it. That's what intermediate value theorem is. And so we really have to say here also, one of the conditions of using the intermediate value theorem is that the function you're dealing with has to be continuous. So if you look up here, they tell you the function's differentiable, and that means it's continuous. So anytime they tell you it's differentiable, it's implied that it's also continuous, because any differentiable function is also continuous. If it's differentiable everywhere, it's continuous everywhere. So we really have to say that in order, anytime you use intermediate value theorem. So we'll say by intermediate value theorem, and I'll put off to the side, since p is differentiable and therefore continuous, and then we can pick pick up where we left off. There must be a value of t between 3 and 6 such that p of t equals 100. Okay, so something like that, but there'll be different ways to explain that. Okay, last one. Okay, total number of gallons of water used by the passengers on the ship is modeled by the function g defined by g of t equals 120t root t for t between 0 and 8, where t is a number of hours since boarding. Okay, find g prime at 4, the rate at which passengers use water in gallons per hour at time t equals 4. Okay, since now we're given g, now we'll just take the derivative and plug in 4. So this is just a normal kind of evaluating the derivative function at some value. Okay, first, and kind of get in the habit of this, kind of two things. Every time you see a root, any kind of root, you're always changing that to a fractional exponent. So we'll do that first. Every time. So you have to get into a habit of, even before you take the derivative, there's a lot of times that you have to rewrite the original function in order to be able to take derivative. For this one also, to make it easier, let's combine these. You know, this is really t to the 1 times t to the 1/2. Okay, so since we're multiplying two things with the same base, we just add the exponents. Alright, so now it's in a form that's good to take the derivative, so we'll just take derivative now. Okay, use power rule. Doesn't matter that this is a fraction, so bring this fraction out front and multiply it by 120. So 120 times 3/2 is 180. And then we'll subtract 1 from the exponent. And if you want, we can rewrite this now, kind of put it back into roots. So t to the 1/2 is square root of t. All right, and then we want to know g prime at 4. Just plug in 4. Square root of 4 is 2. So that's 360. And this is gallons per hour. Okay, so